Assalamu alaikum, everyone. Is my voice clear? I guess yes. Good evening, everyone. My name is Ahmed Azhari. I am the chairman of IEEE King Faisal University Student Branch. Today, we are more than happy and we are honored to start our technical webinar series that's talking about renewable energy and power system. Today is first day. It will be as 7 days. Go through 28 February until 16 March. Today will be first day with Dr. Mohammed AlAqil. As you see in the picture, we have more than we have 7 speakers for 7 days, or sorry, 9 speakers for 7 days. 6 speakers will be for 6 lectures, and last lecture will be for open session. All the speakers have huge knowledge about their fields, and they are more famous, and we will be very happy to host them. Let's welcome Dr. Mohammed AlAqil. Welcome, Dr. Mohammed.
وعليكم السلام ورحمة الله وبركاته. Thank you very much, Ahmed, for your introduction, and we would like to welcome everyone on board on today's session.
Doctor, you can share your screen and start.
I hope that everyone can see what I'm sharing, my presentation slides. So, Assalamu alaikum wa rahmatullahi wa barakatuh. Good evening, everyone, and I would like to welcome each and every one of you on today's session. My name is Mohammed AlAqil, and I'm a faculty member at the Department of Electrical Engineering at King Faisal University. I'll be honored tonight, actually, to share my presentation on greening the power grid. We'll talk about some causes and effects of deploying renewables. But please allow me before that to thank, actually, or to express my appreciations to the IEEE student branch at KFU and their colleagues at the other student branches who have actually worked very hard to organize this webinar, and we will be waiting for the other sessions as well to attend and exchange knowledge and expertise. So again, I would like to welcome everyone on this presentation. So before we start talking about this presentation topic, where we'll be introducing the greening the power grid, and we will talk about some causes and effects of deploying or connecting or integrating, if you wish, renewables into the power system. And I will talk about different levels in the system. So I'll be talking about the transmission and the distribution system as well, particularly. Okay. Moving on, I would like to share the outline of the presentation before we talk about the technicalities of the topic. So just very briefly, what this presentation will cover is basically the utilization of renewables to green the power grid. What are the challenges? What are the drivers, actually, of greening the grid? And we will move on and look at an overview of the existing power network, how it looks, what the existing components within the existing power network look like, and then we'll move on to see how the future network is evolving and how it is improving continuously. And then we will move on to talk about the causes and effects of connecting renewables into the grid. On the transmission and distribution levels, we'll look into some main challenges, and we'll look into some innovative solution, which is the next element on the table today. So we'll look into some innovative solutions to cope with the increased utilization of renewables on the transmission and distribution levels. And then we will be exchanging questions and answers with our audience, and it will be I'm sure it will be an interesting and fruitful discussion at the end. So our first element that we'll talk about is the utilization of renewables to green the power grid. So what are the drivers? So we're trying to answer why we are utilizing renewables into the grid. Why do we want to make the grid green? So I'd like to start with a very generic introduction before we talk about the power system and the power network. And we all know that most of the countries nowadays are being dependent on oil and natural gas as the main source to the energy needs, especially in delivering electricity to consumers. This has been creating lots and lots of questions as knowledge has, been progressing, and then we have seen that some new trending topics becoming on the list, and this has actually included the environmental and economic reasons of replacing these fossil fueled energy sources. Actually, we're talking about oil and natural gas. So basically, we have two main elements that are driving us to move from these fossil fueled sources, which are the climate change and the economic, or in other words, political, call it if you wish, reasons. So when we look on the climate change, as we can notice on the graph presented on the right-hand side of this slide, we can see that since for about 70 years up to 2020, starting from 1960, the recording of the CO2 emissions has been significant, showing a significant increase through the years, and this has initiated actually the that lots of with time it has initiated lots of efforts to try and minimize or reduce the CO2 emissions, and as they call it, and save the environment. So we have to maintain this climate change. So within the environmental causes that are driving us to to utilize renewables is basically the increase of the average temperature. If we look into climate change, the rise of the sea levels, this is again another environmental effect. And we have also noticed that there is a huge increase in the carbon emissions that has led, possibly, I would say, to climate change. And moving or shifting from the climate change into we have to consider another factor into the equation, which is the economic and political reasons of why we have to deploy renewables into the system. A part of the environmental causes, we are looking into economic reasons, such as the growth, the need to grow a new sector, actually, a new economic sector, which will be the sector of renewables, and we can see that huge investments and huge amounts of money are being injected into economics all around the world to support the renewable energy sector. Actually, as we see that they have been they are being implemented almost everywhere now in poor and as well as rich countries. So there is a huge investment in this sector, and for this is one of the main reasons, a part of the climate change that we hear all about in the news and everyone is talking about. It's actually more, I would say, about economic. There are some economic reasons into the equation, and of course this will enable or increase the recruitment or the jobs, the availability of jobs within utilities, within communities, and so on. So this is if we are going to talk about why we are looking to green, if you wish, call it green, to green the power industry. So there are many reasons, but just to start with these generic reasons of climate change and economic reasons. These are, we have to consider these as well as part of the drivers when we look into deploying renewables. Also, I would like to just clarify some terminologies that we might mix altogether when we talk about renewable energy, when we talk about the clean energy sources, actually. So when we talk about renewables, we tend to mix more than one term together, actually. So, for example, when people started, or when researchers and investors started to look into this issue of replacing fossil fuels, they came up with a term called alternative energy sources. This term is commonly mixed with renewable energy. So I would say that alternative energy sources are actually the sources that are um, replacing the fossil fuel energy sources without harming the environment by natural materials, let's say. So replacing fossil fuels by natural existing materials, such as wind, using the sun, for example, for solar energy, using geothermal or ground, let's say, thermal energy, using including nuclear power. So when we talk about the alternative energy sources, we are including nuclear power. I know that when we talk about nuclear powers, there's a huge debate whether this is some kind of a clean energy source, because it is actually very harmful to the environment, but it is considered as an alternative energy sources. So that's when we look into literature, when we look into the book of terminologies. When we talk about energy sources, we have to consider, we have to take this into account. We have to be careful when we, talk about the different energy sources. So this is what we mean by alternative energy sources. So using natural materials as a replacement for fossil fuel, this can include nuclear power. So the aim of the alternative energy sources is similar to that for renewables, which are associated with replacement of fossil fuels to reduce pollution, reduce CO2 emissions, and environmental issues associated with the extraction process of fossil fuels, including oil and natural gas. So this is one of the main terms that have come up as one of the first efforts to produce or to come up with an alternative energy source. So if we talk about renewable energies as another terminology, so renewable energy is, by definition, this is how it is defined by, this is the standard definition by regulators actually all around the world. This is the common definition of renewable energy sources. So it is that source of energy that is being permanently available, and it is guaranteed that it will be always existing. So this is, and also taking into account that it will not harm the environment and it will be environmentally friendly. So for example, if we talk about wind, solar, geothermal, and waves, for example, these are all sources of renewable energy. And from these definitions, now we know that alternative energy, and we have another terminology that is renewable energy. From both of these terminologies, we can say that all renewable energy sources are sustainable, but not all sustainable energy sources are renewable energy sources. And here in my definition, I'm taking into account the environmental effect, because one of the alternative sources, as we said, is the nuclear energy, which can be sustainable, but it's not renewable based on this definition because of its harmful um, consequences if something wrong goes with implementing nukes. Um, So there are a variety of existing renewable energy sources that has been implemented all over the world, and these are actually different from country to country, from utility to utility. So there are and lots of renewable energy sources that we have seen being implemented for so many years now, including solar energy, wind energy, geothermal, CSPs, hydro energy, biomass, and so on. The list goes on and on. But the main question here actually is which combination of these renewable energy sources is suitable? So, what factors will be affecting our selection of these renewables within our system? This is what I will be discussing in this slide. So we are talking about the deployment, let's say, of energy of renewables into the system. And as we know that there are so many different types of renewables, what I want to express or to highlight in this slide is that there is no one combination of these different renewable sources that can be deemed to be as a standard combination and can work in any country all over the world. So there are some factors that will affect the selection of the different renewables existing and to be implemented. And these factors include the environmental and economical factors actually. So we're looking at these two factors: environmental, how suitable our location is to that sort of renewable that we are intending to implement. And we are looking also into the economical factors. So we are investing, of course, in these renewables, but we want to invest in something that will be sustainable in our system and will help us to reduce our dependency on fossil fuel resources. So I'm giving this example just to show how diverse actually this selection can be when we talk about different countries, different locations. So as I mentioned, there is no standard connection or combination of these different renewables into the system. It depends on the environmental as well as the economical factors. So let's take two different countries as an example to highlight this point. So the deployment of renewables. So I have selected two countries in this case, in this comparison. So for example, we have Finland, uh, and we have, on the other hand, Costa Rica as another example. So these are two so different countries with very, very different environmental conditions and economical performance as well. So looking into Finland, let's have a look on the combination of renewables that are deployed within Finland. For example, we see that the majority of renewables are based on the hydropower, which has 70% out of the other renewables being deployed in Finland. And we see that in the second place, we have the geothermal, and then we have some other sources that are not being, not producing or not covering lots of demand, in this case for Finland. So we see that they depend on hydropower and geothermal, for example, in this case. If you are not familiar with what we mean by these renewable types, I will be discussing this very briefly in the upcoming slides. And on the other hand, as we mentioned, we have Costa Rica. So we see that the majority of renewables, the main renewable source, let's say, that they depend on is the hydropower in this case, which has 78%. And then we see that geothermal has the 10%, and then wind has also 10%. And then we have another 2% that is from other sources. So um, this combination of different renewables into the system must be studied very, very carefully and thoroughly when being implemented or applied in a country or somewhere. And because of like for the Costa Rica example, we see that it happened that in 2017 and 2018, about 99% of energy was supplied from renewables for about 300 days. So we see that in these 2 years, they had almost all year actually of most of the time using renewables as the main source to supply electricity to um, in the grid. So we can see that this combination, if it's studied well, then we can rely on renewables as an alternative to our natural fossil fueled energy sources. However, there are some risks. I'm not saying that we can depend, if we can depend on renewables, then this will solve our issue and we will not be depending on fossil fuels, but there are lots of challenges that we have to consider when we talk about the technicalities within the power system network on the different levels from transmission to distribution. So what about us? What about Saudi Arabia? What will be our combination of energy? So based on a forecasted study presented by King Abdullah KA Care actually. They presented these numbers back in 2018, I believe, and they are forecasting that this is the combination that we will be looking at when in the case of KSA. So we are looking at solar PV systems up to 16 gigawatts will be deployed. And this study is, I'm not sure if numbers have been updated, but this is the forecast for 2030 up to 2032 since 2018. So the solar PV system will be providing up to 16 gigawatts, and then second place, or with it, I would say, with it, we have the solar CSPs, which will provide 25 gigawatts, and looking into wind energy, which we have up to 9 gigawatts. Then we have the biomass, or let's say waste to energy, about 3 gigawatts, and then we have geothermal as 1 gigawatt. So this is our combination, and this combination has been studied for so many years, I believe, so that we can study the geographical location of our land and to see what combination of renewables will be best based on the environmental as well as the economical aspects of this plan. So this is, if we are looking at the combination in case A, this is what we are looking at. These are the types of energy sources that we will be depending upon to lift our hands for some time over for fossil fuels being used for electricity um, generation. So if we look into more details, we can see that we are almost approaching um, 2022 in this case, which has been forecasted um, to have the wind energy being introduced, and we have seen that this happened actually since in the previous couple of years. We have some wind energy now being in operation. So if we have a look and analyze this forecasted energy combination, we see that there will be more investment on wind and solar systems, PVs or CSPs, um, to be implemented, and the fossil fuels will be reduced with time. So if you are looking at what kind of renewables will be utilized in Saudi Arabia, this can give you some insight about what kind of renewables we are looking at. So we are looking at nuclear as well, as I'm highlighting, which can be, as we mentioned, an alternative source, and it will be implemented, but we're looking on some other renewables that will have more investments as well. So this is a general idea about different renewable energy sources, what kind of combination is suitable for us, and so on. So these are the factors. This is what the other countries are implementing, and this is what we will be approaching up to 2032. And in this graph, we can see that up to 2050, actually, we will be depending more on solar energy. Okay, so before we talk about the challenges in the system and how these can affect actually the performance of the power system, I mean the integration of renewables into the system, I would like to very briefly go over upon the request of most of our audience. I'd like to go over to provide an overview of the renewable energy sources that will be implemented in KSA and how they work actually. So if we look into solar photovoltaic or solar PVs, power plants, and how they operate, uh, just very briefly, what we see is actually that we have a solar power plant that is so we have lots of these PVs, and then the way it works actually, we have a power plant that consists of the energy source, which is in this case the solar energy, that is generating a DC current in this case, and this DC current is being inverted using some inverters into an AC current that can be supplied or can be stepped up and can be connected into the existing grid. So this is, in general, this is if we look into the different renewables, this is the main idea actually. So we have our source is one of the renewable energy sources, and it will be generating a DC electricity that will be converted into AC electricity that can, or AC current in this case, that can be supplied into the grid if it is connected onto the grid, or it can be locally used if it is off grid. So this is what happens when the sun hits the solar panel. We can see that we have electrodes basically, and we have some semiconductor materials where we will be generating these charges within the semiconductors, and therefore we will have the DC electricity generated, represented by the plus and minus in this case. So we'll have DC that will be supplied into the grid as an AC by inverting the electricity. And if we look into the other type, which is the concentrated solar panel, we can see that it uses almost the same approach, but in this case, the panels that we use are parabolic and sometimes, so they are curved in some designs. They are not flat as it is for the PV normal PV system. So you have a parabolic shaped mirrors in this case that will be redirecting the sun light into a chamber in this case with or a heat or a receiver point in this case, which has a liquid in this case, which can be water, and that is being heated due to the redirected sunlight. And then we can generate, if we go back and look at this diagram, we can see that this water that is being circulated here will be transformed into steam, which will be driving the turbine, and then from the turbine, this turbine can be connected to a generator basically, and can be fed, electricity can be fed into the existing grid. So this is just very briefly what CSP is all about as compared to the normal photovoltaic solar system. And if we move on to the wind power plants, we can see that the basic idea actually is that we have some blades in this wind turbine that will be hit by wind, then it will rotate at a very low speed because of its size actually. And then after it rotates, if we have a look deeper inside, if it rotates, then it will be accelerated uh, by a shaft that is placed or connected into a gearbox that will be rotating the generator and generate a DC again. It's DC current that will be inverted and can be fed into the grid by stepping up the generated power in this case. So this is just very briefly what happens or how we generate or from wind farms, how we generate electricity and connect that into the grid. We have also hydropower, which I would like also to mention here, although it will not be one of the common in KSA, but it is one of the common in so many countries uh, over the world. So it's basically using two reservoirs within the system. So we have one reservoir on the top and another reservoir on the bottom, and the water will be flowing at a very high speed at the intake from the upper reservoir, and due to its speed, it will be hitting a turbine on its way, and then this turbine will rotate, and then it is connected to a generator, and when it rotates, it will be generating power, and this power it will be stepped up or will be connected into the grid by transformers. So this is one of the common um, um, renewable energy sources that is being implemented. So I just wanted to share that very generic explanation or description of the different renewables or most common used renewables over the world. Okay, let's look into or let's review the structure of the existing network and how it is being improved or what will be different in future networks compared to the traditional network on the transmission as well as the distribution level before we talk about the challenges and the solutions in the transmission and distribution system. So we are familiar with the traditional power system where we have the power is flowing from one source, one generation source, moving through the transmission system and then distributed to consumers through the distribution system. So it is in the traditional system, it is one-way direction of the power. And this one-way direction of the power is we can refer to it as a passive performance of the circuit, actually, because the electricity is generated from one point, it reaches the other point, and then that's it. But for the future networks, as we will see in a moment, it is not the case. So power can be transferred either way, from the source to the consumer and from the consumer to the source. And in this case, the consumer can actually alter or can play a role in altering the power flowing within the network. So it's in this means this is what happens or what the difference I mean between passive and active. So we're talking about the traditional system, the passive radial system, and the active system where we have for example, distributed generators within the distribution system. So the integration of renewables in this case can be on the transmission level, the high voltage level, as well as the distribution level. So this will bring some challenges into the network when we deal with the power network. So just to emphasize or just to clarify what we mean by traditional system, I would like to mention this as I like to repeat it again and again in my talks. So just to make sure that we visualize how a traditional network looks like. So for traditional networks, you have the source, which is, for example, fossil fueled uh, power plants that is generating electricity up to the consumers. So we said that this is a passive, let's say, performance of the network. So from one point to the other, and that's it. But for future networks, it will not be the case. Let's talk about the transmission level, for example. For transmission level, you can connect renewables into the transmission system, and and then we'll have different or more generation, let's say, reserves within the system. So we will have the renewable energy generation as well as the fossil fuel in this case. And this will bring lots of complexities within the existing network. So what will happen to the network? So the existing network is existing for so many years. Will it be able to comply with the connection of the new renewables on the transmission level? As this might bring actually more challenges. And we know that renewables, most of the time, they are connected remotely and they depend on the weather, so they are unpredictable. So we don't know how much will be generated from these renewable energy sources as long as the weather's all the time changing. So this will be one of the challenges, how to forecast the generated um, electricity from these renewable energy sources. So this will be challenging actually, and this is what we are looking at in the future power network on that transmission level. So this might bring some complexities, as I mentioned, on the transmission system. For example, it can congest the power flow within the transmission system, and we need to make sure that if these renewables are connected into the transmission system, the transmission system will be able to withstand the connected renewable energy sources. And looking also into the distribution system, we see that there will be some distributed generators, as we call them, within the distribution system. And these distributed renewables will be penetrated or will be connected into the distribution system. So this will also bring some complexities within the distribution system, and we need to make sure that our distribution system can maintain the different scenarios, let's say, that might face or might that it might face due to the altering all the time wind and PVs, for example, or any other renewables connected within the distribution system. So we can see that there are challenges within the transmission system as well as the distribution system. And if we visualize how the network will work. So in an effort to simplify what challenges we are looking at and what solutions should be provided, we are looking at um, basically renewables and the causes and effects of connecting renewables into the grid. So, of course, connecting renewables into the grid will have some um, positive consequences as well as negative consequences. So, the positive consequences that we have, that everyone talks about, actually, when we talk about renewables, um, we can say that it will, of course, relieve in line congestions if we use them locally. So we can, for example, use the power locally and depend on renewables in some cases. And we can also say that one of the positive consequences of connecting renewables is that we will have some kind of an energy security in this case if nothing disastrous happens. So we can say that it is one kind of energy security. We can depend on these if we have any other issues with the other fossil fueled energy sources. And we can say that positively, we can reduce the pollution and global warming as well by utilizing these renewable energy sources. Of course, there are some negative consequences as well, and this is rarely being talked about, a part of the researchers in power systems. And we can say that the renewables create lots of technical issues when we deal with on the transmission level, on the distribution system. We'll see this in a moment, actually, what list of technical issues we can expect. And of course, we will need to continuously review the standards for the power system network, as we have to comply with the standards and we have to update them all the time. And this will also require some investment in the network to maintain the performance of the network and to make sure that we maintain the integrity of the network when connecting these renewables. Okay, so there will be some technical challenges brought into the power network, and this will involve lots of investment possibly to find some innovative solutions. So on the transmission level, what kind of challenges are we expecting? So we are expecting that some main challenges that we can talk about. For example, the expected high growth in demand, which is being a continuous challenge actually. So the growth is being increased continuously. And then we can say that increasing the integration of renewables and the increased utilization of renewables within the network is another challenge. So these renewables are being invested on and being utilized as well. And they are connected remotely, and this will be another challenge. So connecting renewables remotely will require that these renewables must be connected to the existing power network, or the power being generated, if not being used locally, then this somehow must be transferred through cables or underground cables or through an overhead line system, and this will require investment as well. So these are some of the challenges that are associated with the connection of renewables on the transmission level. So what are the limitations of to overcome, or what are the limitations of increasing the utilization of renewables into the system? We are basically being limited by two main factors: the financial constraints as well as the capabilities of the existing assets within the network. So these are the two main factors that are limiting us from connecting renewables into the system. And so the solutions to overcome these limitations rely on two main factors. So basically, intensifying the asset maintenance. So we can, if we can maintain the existing components while we are increasing the renewables, depending on the maintenance schemes that we follow, this will help us to still, because remember, these are connected remotely. So if we can do so, then this will help us to increase the utilization of renewables. And the other element, the other set of solutions will be if we can guarantee the end of life of the existing components within the network while we are increasing and aging our network, actually, then we can increase the utilization of renewables. So we are being limited by these two main factors, and we need to find some innovative solutions to increase the utilization of renewables. If we look into the distribution level, looking into the distribution level, we can, as we mentioned in the previous slide, the distribution system will not be, or is not, if we implement, for example, distributed generations and so generators and so on, the power flow will not be in one direction, will not be radial. In other words, um, it will not be passive. So the network in this case, if we connect renewables, it will be active. So the power will be transferred within the network, within the distribution network, back and forth actually. And I'm referring to the active power and the reactive power in this case. So we're talking about P and Q. As we can see in the diagram provided on the right hand side, if we look into a distribution bus, for example, this 11 kV distribution bus. In a radial system, we don't have all the other distributed generators connected into the bus. We have only one way of flow of the power from the grid, let's say, from the transmission into the distribution. But now we have these renewables being connected onto the same bus where we have our load, and this will make our distribution system complex. So what kind of challenges are we looking at due to the connection of these renewables into the distribution bus alongside the loads that are already existing? So we're looking at some common challenges that have been reported actually by utilities. So the survey says that um, there are 6 main challenges for integrating renewables into the distribution system. So looking into the point of common coupling and the voltage level on the bus, so it might be violated due to the connection of these renewables. And we're looking also at the voltage variations and power quality issues within the distribution system. We're looking at reactive power compensation, frequency regulation, which is another important factor actually, and of course, not forgetting the protection issues. So I'll be going through very quickly some 4 out of these 6, which are the most common. So if we look into the point of common coupling, the PCC as we call it, which is this point, which is the point where the load is connected, and we have also the other DGs and renewables connected into the same bus. So to make sure that connecting these renewables into this bus where we have the load, this will need that to make sure that this bus is strong enough and it does not affect the system if in the case if something happens to these renewables that are connected to this bus. So if these renewables are being, for example, offline for some reason, the PCC point should be strong enough so that it does not cascade, let's say, any problems within the network to the distribution system. So this is one of the common challenges within the distribution system, and the variation in the renewables within the distribution system might result in voltage variations. So the table that we see in this slide is based on IEEE standard 519, which states that for different voltage feeders, we should limit the renewables and the DGs that are connected. And this is based on statistics, actually, as they mentioned, but this can be, of course, um, can be improved later on, but it gives again some insight on looking into the feeder size, how the level of renewables that can be connected. So this is one of the challenges. Looking into another challenge, which is voltage variations and power quality issues, we are looking at, for example, if we look into this distribution system, we can see that we have 2 feeders connected to this distribution bus. The first feeder is the passive connection, and as we said, what we mean by the passive connection or a passive circuit is that we have only on this feeder normal loads as we have normally. But adding one DG, for example, into the feeder, let's look at the other feeder. So adding one DG will make the circuit become active, which means there will be power going back and forth because of this DG. So what kind of problems we are looking at? Because of this DG connected to this bus, we might, of course, we're looking at the distance from the distribution bus. So from the distribution bus, the voltage, we can see that the voltage drops, of course. But due to the DG, because this is active, there will be some power going back and forth, P and Q. We might face some over voltage issues. So we might violate the upper or the maximum voltage of the bus. And without any DG, we're looking at the passive connection, we can see that we will violate, but we will be below the minimum voltage. So this is what we are looking at actually in terms of the types of violations in terms of voltage variations within the distribution system. We have also what we call as voltage ride through capability, which is another characteristic of the distribution system. And this actually voltage ride through capability is can be described, or it is different from utility to utility, which is the time that it takes or the allowed time to make the renewables offline and then restoring these renewables. So this depends actually on the country and its standard, and the restoration time varies actually, and there is no one standard. It is based on experience as far as we know from the IEEE standard 1547. So this is what we are looking at from the voltage ride through capability. If we look into the reactive power compensation, if within the network, if we look into the different types, for example, of wind turbines. So we have fixed speed wind turbine generators, and we have variable speed wind turbine generators. And if we look into the fixed speed wind turbine generators, the compensation of the reactive power is normally through capacitor banks, okay, to compensate the reactive power, the reactive power within the network. So the renewable source itself does not contribute or does not participate in the system voltage control, because we still use capacitor banks because it's fixed speed. But for the variable speed wind turbine generators and solar PV systems, we can sometimes we see that self commutated actually power electronic devices, which are, in other words, because it's variable, the renewable energy sources are varying, and we can control its performance, then we can use it to compensate for the reactive power within the network. So this is another challenge within the distribution system of connecting renewables. Looking also into another challenge, and another important actually challenge, is the frequency regulation capability of the network. And we can see that for the frequency regulation within the network, we need to make sure that we take into account the penetration, for example, of the different renewables. If we take this example in this case, and we see that we are penetrating, in this case, wind energy from 0 to 50, we can see that as we are increasing the load or the penetration of wind within the network from 0 up to 50%, we can see that there is a significant drop in the frequency. And of course, this is without any inertia with a weak inertia within the system. And we know that our power system is, or the capability of power system to maintain the change of frequency is based on system inertia, which is dependent on the rotating machines, let's say, within the system. And if you want to think about it in other ways, think about if you have a vehicle, for example, that is 4 cylinders, and you have another vehicle that has 12 cylinders. Which one will be able to catch up if it is slowed, for example? So this is one way of thinking about it. This is what we mean by inertia. So it is an important characteristic and another challenge within the distribution system. And I will move on to very quickly through the solutions of the connecting renewables. So for the transmission system, we are looking at some solutions within the network operation. So we're looking at the overall network. So these are based on the transmission level solutions. If we have any problems associated or any challenges associated with the capacity of the transmission system, we can always think of demand response to balance the supply and demand. We can think about energy storage to store the energy and use it at some point when we need it. We can think about dynamic line rating to monitor the transmission system and to distribute the load to avoid congested lines. And we can think about emergency operation as well. So this will be, these kind of solutions, when we look into the network, will be two-way communication, as we have said. It will be an active circuit in this case, so between demand and supply through the transmission system. So going through the solutions, the other set of solutions where we are trying to look into the existing assets within the network, we can always expand the network if we need. If we have any issues with connecting renewables, we can use some technologies within the network. For example, some kind of new conductors that will carry more energy, or more power within the system. And this will be basically based on the transmission system assets. So insulation system, the conductoring system, and so on. If we look into the distribution level solution, I will focus on interconnecting more distributed resources. So if we interconnect more distributed generation within the distribution system, this will help us to have more flexibility within the network. So instead of having one geographical area or one separate area where we have all the distributed generations, we connecting these distributed generations into the distribution system will help us to make the network flexible and to alter if it can withstand the varying renewables connecting into it. So with that, I will close. And I would like to thank you again for listening and for paying attention. And we are glad that, or we are wishing that this has come into your standard and this is what you're expecting. And we welcome any questions. So I'll pass this back to you, Ahmed, and thanks again.
Thanks, Dr. Mohammed. We were very interesting and it was very knowledgeable. So thank you, Dr. Mohammed, again. So, guys, if anyone have a question you want to deliver to the speaker, please can write it in the chat. Okay, guys, okay, if there is no question, we would like to remind you that there is a Google form for attendance. We send it in the chat. Please, everyone attend here need to follow to fill it. So there is question, no? Need to fill it so we can bring him a certificate in the end of the technical webinar series. Thank you, Dr. Mohammed. We would like to thank the team of our team and remind you that we have another lecture on Wednesday, inshallah, on 3 March. And follow us on Twitter and YouTube. Subscribe to follow every uh, every new news. Thank you, Dr. Muhammad. And if there is nothing, we can close now.
Thank you very much. I'm not sure if there are any questions because I don't see the chat,
No,
to be
we
honest.
can
So
see
there are no.
they thank you so much and nothing about the lecture. It was
Okay. Thank you
it
very
was
much, and we'll be waiting for the other sessions.
okay. Thank you, Doctor.
Thanks.